Hello class, it's Miss Castillo here. So I hope you guys paid attention to Miss Nancy as she passed out the items that we will be using for this experiment as well as listening to the instructions. I will be covering the explanation part of our 5E lesson plan. Part of that is discussing our expected results. I'm pretty sure Nancy covered with you guys that you guys needed to make your own predictions. In other words, guess which items of the items that she handed out were going to sink and which items were going to float. So we have a total of 8 items, right? We have, can anybody tell me? Okay. So we have the Play-Doh, the penny, the bobby pin, the piece of wood, the styrofoam, the plastic ball, the pencil, and the shell, right? Okay, so you guys were supposed to make your predictions and write them down on your worksheet. So I'm going to share with you guys my predictions, what I feel may happen, right? So I think that the Play-Doh, the penny, the bobby pin, and the shell will sink, and the block of wood, the pencil, the plastic ball, and the styrofoam will float. But we're gonna have to wait and see until we test it out, right? So in order to kind of give you guys an idea and a little kind of background story to it, I decided to share a short animation clip about sinking and floating, which will kind of help explain to you guys that floating and sinking is a characteristic of an object no matter how much it weighs, okay? But I want you guys to pay attention because during this short clip, it does ask a few questions, which I would like for you guys to answer as we go through it. Just that way I see that you guys are understanding our lesson, okay? So I will be sharing with you guys just now. We're going to start with the first question, which I will be showing to you guys over here. Okay, so the first question is, the wood and the metal are the same size, but the wood is lighter. You see there, the wood is 5 grams, the metal is 40 grams. Which do you think will sink or float? So, who can make a prediction? Who thinks the wood is going to float and who thinks the metal is going to float? I would like to see a raise of hands of who thinks the wood's going to float or sink. Okay, so who thinks the metal's going to sink? Raise your hand. Okay, so as shown here in the little animated tank, water tank, we see that the wood the piece of wood floats and the piece of metal sinks, right? Now, how about a bigger piece of wood that weighs the same as the metal? So now they weigh the same, right? They're both 40 grams. So do you think the wood sinks or the wood floats? Who thinks the wood sinks? Raise your hand. Now, who thinks the wood will float? Okay, we're gonna see. So the wood still floats, even though it was bigger than the metal. Even though it was the same size as the metal, weight wise, it still floats. Why is that? So how about an even bigger piece of wood that weighs more? That's more, guys, more than the metal. So the metal weighs 40 grams and the wooden cube now weighs 140 grams. So do you guys think the wood will still sink or do you think it'll still float? Okay, let's see. Let's reveal our answer. So no matter how much the wood weighs, it always floats. Why is that? Because floating is a property of wood. Interesting. So how about 2 different items now? Now they're using a candle, which is made out of wax, and an eraser, which is made out of rubber. So the candle and the eraser are the same size, but the eraser is heavier. So which do you think will sink or float? So we see that the candle weighs 10 grams and the eraser weighs 20 grams. Which ones do you guys, who thinks the candle is gonna sink? Raise your hands. Now, who thinks the eraser is gonna sink? Let's see. So the eraser sinks and the candle floats. We see how the eraser right away it's sunk to the bottom of the little tank and the candle stayed up. But what about a smaller eraser or the same size? How about a smaller eraser that weighs the same as the candle? So now they both weigh the same. So do you think they should both float because they're the same size, the same weight, I'm sorry? Okay, let's see. So once placed in the tank, you see that the candle stays up, but yet the eraser still sunk. Why is that, guys? Why did that happen? Okay, so let's see. Let's try one more time. How about an even smaller eraser that weighs less than the candle? So now you see this little tiny piece of eraser right here. You can barely see it, but it's right there, guys. It weighs 1 gram, almost nothing. And you have the candle wax that weighs 10 grams. Do you think the eraser is gonna sink, or do you think it's gonna float? Who thinks it's gonna sink? Raise your hand. Okay, so who thinks it's gonna float? Raise your hand. All right, let's see. Dun dun dun. Okay, so no matter how much the eraser weighs, it always sinks. It's sunk, guys. It's over here. You can see it, but it's right there. It's sunk. Why is that? Because sinking is a property of rubber used for erasers. So that explains a little as to why those items floated and the other one sunk. So in this case, we had the metal and the rubber eraser that sunk, right? And then we had the wax candle, and we also had the wooden cube that floated. Why did the cube float? Can anybody tell me? Do they remember from the video the reason why wood floats? Okay, good job. Because wood is a property of floating, right? And rubber was a property of sinking. So good job. But here's the thing. What if you place a crayon in a little tank full of water? Well, that's the tricky part. Now, what if you put a rubber band inside a tank? Do you guys think they'll sink? They'll both sink? They'll both float? Or one's gonna sink, one's gonna float? Well, here's the catch on that. Because crayons have wax, right? Crayons are made out of wax, but they're not fully wax. And if I were to show you guys I don't have a tank with me, but I do have a dry board eraser where I wanted to show you guys. So let's say that we place a crayon, right? This is our tank. And that's our water. Okay, I'm not an artist. This is our tank and that's our water, right? So if we were to place a rubber band right here at the top, like I said, guys, I'm not an artist. Just take out the water there. Okay. If we were to put, that's a rubber band, guys. This is a rubber band. I'm gonna put rubber band, okay? So if we were to place the rubber band at the top, do you think it's gonna stay there at the top, or do you think it's gonna float? What do you guys think? Who wants to guess? Okay, so some of you guys, I see that some of you guys think it's gonna sink, some of you guys think it's gonna float. Okay, well, okay, let me add the crayon. I'm gonna put the crayon here. It can be any color you guys want. It's a crayon. Let me write crayon. Okay, they're crayon. Okay, there you go. We have the rubber band and we have the crayon. So certain objects like these guys, like the rubber band and the crayon, may seem to float when they're first placed in the surface, with the surface of the water, I'm sorry. But these objects, in this case the rubber band and the crayon, are actually supported by the water tension, and they're not truly floating. It's like it's kind of like when you float on water, but somebody's kind of carrying you, right? You're not really floating because someone is helping you. Well, here, for the rubber band and the crayon, water tension is helping them. That's their support. So it's not truly floating, and as a result of being less dense than water, that's why. So if I were to touch, right, if I were to push down the rubber band just a little bit and the crayon just a little bit, like let's put it, like if we were to push it down here now, right, and the crayon, we'll push it down over here. Like I said, I'm not an artist, guys, but I'm trying to, you know, draw, right? So we're gonna erase this one, and we're gonna erase our rubber band because it's no longer at the top of the water surface. Now it's a little bit below that. So will it stay there? Will it float there? Or do you think it's gonna sink like more? All the way to the bottom? Do you guys think it'll sink all the way to the bottom, or it'll stay there? Okay, so if we were to, like I said, since we already pushed it down, right? If we touch the rubber band to this level of the water, and it's below the water surface, this is the water surface, right, what the little waves are at. Okay, so they would actually sink, guys. It would not stay there. It would actually fall down, 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 down to where the rubber band is right here, and to where the crayon is all the way at the bottom of the tank. Okay, and I know some of you guys are probably like, Miss, why, right? Well, like I said, a crayon, yes, it has wax, but it's not completely wax. It's because the crayon is made mostly from wax. Most crayons sink, right? But because of the added pigments that they have and other substances used to make the wax, and the rubber band, it's still rubber, guys. Remember, rubber was one of the properties for sinking. So like I said, it has that support while it's at the top, but once you kind of like push it down, it's gonna go down, 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 and hit the bottom of the tank. So that's the reason, and that's my explanation as to why certain items sink and certain items float. Some of the characteristics that have to do with it is, it doesn't matter how big or small it is, or how little or big it weighs. If it's a property of sinking, it'll sink. If it's a property of floating, it'll float. As long as it's a regular shape, such as a cube or a sphere, I mean, the science is there, guys. So thank you very much for paying attention, and I will leave it all to Marco to continue on explaining and elaborate a little bit more about the science behind our sinking and floating experiment. Thanks.